In this lesson, we're going to talk about architecture. And to understand a good architecture, first I'm going to show you the problems of not having a good architecture. So remember main activity. We have implemented the product screen and we also integrated the API. Now let's imagine if this main activity is going to do both of them. Voila! And now we have an activity which takes care of both API integration, as you see here, and also implementing the layouts. And let's not stop there. Let's also add stuff like error handling and user interactions to it. Again, voila. Here we go. Now we have error handling, and it will get bigger and bigger as you continue to add features and screens. So what are the problems with this? First of all, it's a mix of UI, data, and logic. It's doing too many things. It has too many responsibilities. Imagine having a one-person restaurant. So the owner takes the order, cooks food, serves the food, and washes the dishes, cleans up the restaurant. First of all, he will burn out, but also if the owner gets sick, the whole restaurant shuts down. The second problem with it is that it gets messy really fast. This is what's called spaghetti code. It's hard to read, hard to understand, and hard to maintain. It's easy to break. One thing breaks, everything breaks. And the third problem is that it's hard to reuse stuff. So for example, this API call to fetch the product. If you want to reuse it in another screen, then you need to duplicate the code. And duplicated code is harder to maintain. So we need to save ourselves from this spaghetti code. And that's where MVVM architecture comes into the game. MVVM is an architecture that helps organize the code in a way that separates applications data, which is model, the user interface, which is view, and the logic that connects them both, which is ViewModel. Hence the MVVM, model, view, ViewModel. It was first introduced by Microsoft, but now Google recommends it for a long time. So now let's break it down to its layers. And the first layer is view. View displays data to the user. And view also captures the interactions from the user. That's, for example, pressing a button, scrolling, and so on. And view is the UI, the user interface. We will use these two terms interchangeably, but they are basically the same thing. And in our app, view is the activity and the composables. The next layer, model. Model manages the app's data and the business logic. And it also interacts with local database, remote APIs, file storage, and in-memory data. So in our case, where we manage the data is the fake store API. This is why we created a separate class for it, to have it centralized there. And the business logic is the product data model. And then we have ViewModel. ViewModel separates logic from UI. So it contains a lot of logic. And it also manages asynchronous operations. For example, waiting for the model to provide data, and in the meanwhile, tell the view to show a loading indicator. It holds and manages data. So the data that it gets from the model, it holds them somewhere. And of course, it provides the data to the view. So we will implement the view model later by connecting the view and the model layer together. So in a visual way, the MVVM architecture looks like this. So we have model, view model, and view. View model reads data from model and then provides that data to the view. And user interacts with the view, for example, presses a button. So UI event will be handled by the view model, and then view model writes that data to the model. And in many cases, view model constantly listens to the model for data changes. For example, in case of a chat application, constantly listening to the server to get new messages. So that's when model updates the view model with the new data, and view model gets notified. And in response to that, view model updates the view. So you can see this flow of data from model all the way to the view. But our app is simpler, so we will not have those communications going on. For us, it will look like this. And so that was MVVM. It's an architecture that helps us organize code in a way that separates applications data, the user interface, and the logic that connects them.